So welcome to course G03 on read mapping. This is an introductory video to let you know how this course is structured, the aims and the times that the courses will be on. So we have two main labs on the Tuesday and Thursday, Tuesday 25th and the 27th. These will be in the Plower conference room from 2 p.m. onwards. You'll have time in advance to look at the instruction material beforehand, and then time in between the labs and afterwards again to learn things further as suits you. Notionally, there's up to 20 hours of learning time associated with these courses if you have no prior learning, though you may find that it takes you less time than this if you've worked in this area before. And of course, it's up to you to kind of choose what is most relevant for your particular area. What we will do is make sure that we take things off in appropriate kind of size of chunks of new information so that you understand all aspects of this diverse area from the ideas behind read mapping in terms of theory and sequence alignment to the practical application to existing read libraries. So what we're trying to do is inform our picture of a particular sample using a read mapping approach, and bearing in mind that some reads may not be all that we want, may not all be there, and some reads may be overrepresented. So what we're going to do is learn how to map sequence read libraries to different genomes or genomic databases, and we'll look at how these read libraries can be examined in this manner. I'll also look at short and long reads together. And we'll also look at how read mapping is a kind of parallel process working in tandem with genome assembly. So at the end of this course, you'll be able to map in short and long reads to reference genomes and use read mapping to inform your genomic results. There's more detailed information in the module descriptor. There also have a lot of resources that will be used here, stuff on errors associated with read library creation, Galaxy training network mapping tutorials in terms of a tutorial page, a kind of lecture in the background, an introductory tutorial. And then there's some papers. There's one on Bowtie 2, one of the older read mapping algorithms. This website where you actually work through a read mapping alignment yourself. The classic Lee et al. 2008 paper that introduced a lot of the key concepts in such as mapping quality and read mapping, and then an updated version on Minimap 2 from 2021, which kind of builds on this previous work. So that is the end of this video. Please see video 1 in the series on why you want to map read libraries to reference genomes next.